The prism is made up of glass of unknown refractive index. A parallel beam of light is incident on the face of prism. The angle of minimum deviation is measured to be 40 degrees. So our delta M minimum deviation is 40 degrees. The refractive index of material of the prism is to be found. The refracting angle of the prism, which is given by A, is 60 degree. Now next question is, if the prism is placed in water with refractive index 1.33, predict the new angle of minimum deviation of the parallel beam of light. So when we are talking about the parallel beam of light, as you can see in the figure 2.1 in NCERT, this is the parallel beam of light. And to the parallel beam of light, which is going parallel with some angle A, this is angle A, which is given to be the refracting angle of the prism. So we know that to find the refractive angle of the prism, mu p, with respect to air, we have the formula like sine of A plus delta m whole divided by 2 divided by sine of A divided by 2. So according to which sine 60 plus 40 divided by 2, it is equal to sine of 30 degrees. So sine of 50 degree divided by sine of 30 degrees. Sine of 50 degree we need to find. So 50 degrees, and I'll take sine of it, 0.766. This is 0.766, and in the denominator we know that sine of 30 degree is 1 by 2. So I'll take it 0.5. Again using calculator, I'll get 0.766 divided by 0.5 will give me 1.53. So this is the refractive index of prism. So the next question is, what is the refractive index if the prism is placed in water? Now what will happen if we place the prism in water, and what will be the predict the new angle of minimum deviation? So I'll remove this. So now we are not given with angle of minimum deviation. This is mu of prism with respect to air. So we are not given with the angle of minimum deviation, but still we have refractive angle of the prism to be 60 degrees. So the refractive index of water is given to be 1.33. So the new refractive index, the new formula will become refractive index of prism with respect to water will be given as sine A plus delta m whole divided by 2 divided by sine of A divided by 2. So sine, this mu I can split it as mu PA divided by mu WA. So this is given to be sine of 60 plus delta m whole divided by 2 divided by sine of 30. Why we have done this? Because mu PA you can written as refractive index of glass divided by refractive index of air, and this mu WA you can written, which is being divided, you can write it as mu WA into mu A. So ultimately mu A goes and we'll get mu of refractive index of prism with respect to water. So applying all this, mu of prism we found to be 1.532 and refractive index of water is 1.33. So using this we'll get, with the help of calculator, 1.532 divided by 1.33 will give you 1.51. 1.51. 1.151. Sorry, 1.151. And then I'll solve it again. Sine of 60 plus delta m whole divided by 2 is equal to, sine of 30 is 0.5, 1.151 into 0.5. Taking this to this side. So 1.151 divided by 2, 0.5755. 0.5755. Now we need to take the inverse so that we can further find. So we need to take 60 degree plus delta m divided by 2, sine inverse of 0.5755. Okay, suppose that this is nearly 36 degree. So my delta m will come out to be, it's 35 degree I'll take. It will come out to be 70 minus 60 degree. Nearly 10 degrees will come out to be the angle of minimum deviation when whole prism is put in water.